Hello, welcome back to my channel. This is Yo-Yo. So today we're going to talk about rates of change and the behavior of a graph. So since the function represents how an quantity output quantity varies with an input quantity, it is natural to ask about the rate at which values of the function are changing. So for the most basic, so what is rate of change? Well, for a linear function, which is a straight line, such as y equals to ax plus b, rate of change is going to be a constant number, which is the slope. A is the rate of change. But when it comes to a different function, such as parabola, oh, this is a nice one, which is y equals to a times s plus b squared plus c, something like that, look like that. You're probably more familiar with y equals to ax minus h squared plus k. That's fine. Remember, b and c is just a number or some very general form of that. Okay, let's not carry away. This is a quadratic function. So when it comes to quadratic function, the rate of change is going to change because if you're given these 2 points, from point A to point B, even though this is the same distance, let's say this is the distance of 1 or 2 unit, 1 unit, let's say 1 unit. This part is more stiff, right? So that means the slope is going to be bigger compared to these two parts. Let's say these two parts, this is the same length of AB, let's say CD. And this part is more flat, it's less steep. So the slope, oops, why they were gone? So the slope from C to D is less than the slope from A to B. Does that make sense? So that means the rate of change in quadratic function is going to be different all the time by any given point. So actually, the changing rate is more common than not changing rate of change. This is a special case that they have a constant rate of change. So remember, how do we find slope? Slope m is equals to y1 minus y2 over x1 minus x2. So how do we define y1 and y2? So y1 and y2, x1 and x2 is just two given order pair, right? So now we learn the function notation. We don't use y anymore, we use x. We write it as x f of x1 and then x2, y2 is become f of x2, right? It's the same thing. Remember, y1 is equals to f of x1 and y2 is equals to f of x2. They are the same thing. Remember that. So the rate of change is going to equals to f of x1 minus f of x2 over x1 minus x2. Basically, it's y1 minus y2. If you feel like s1, s2 is confusing, you can use a and b. F of a minus f of b over a minus b. So by the definition, we have, because look, every time you change, right, the rate of change. So in this part, we can find two dots. Connect these two end dots together, and these connect these two end dots, you will have a straight line. And then the rate of change, which is the slope, we will call it the average rate of change. So what's the differences? Well, let's draw another graph, and then I can draw a bigger graph. You will watch it more clearly. Maybe this is not clear enough. So let's say this is point A, this is B, and then this is our corresponding FA. This is FB. Okay, so when it comes to average rate of change, well, basically is connecting these 2 points and find the slope. But in fact, if you watch it clearly, if I zoom in, oh, I can zoom in. I can zoom in, but if you pay close attention to it, this is a curved line, right? So that means in any given point, this part, if I average them into 1, 2, 3, 4, 5, 5 section, the rate of change in 1 is different from the rate of change in 5, right? Because 1 is more flat compared to 5. 5 is more steep. So when it comes to rate of change, basically is you divide this section from point A to point B into infinite many points and find the rate of change, and then combine them together and find the average number, the mean. So to make it easier, we just basically connect these 2 points with a straight line and find their slope. So again, it's a slope. So the average rate of change, which is ARC, it's really common to see that, is equals to f of A minus f of B over A minus B. Remember, it's the changing of output over the change of input. Okay. So now let me give you an example. Okay, so in this example, on a road trip, you decided to record your distance from home over the town. Find your average rate of change for the first 6 hours. This you've been recording for 7 hours. So now let's take a look. What is from the 6 hours? That means from 0 hour to the 6 hours. So think about when you're driving. Sometimes you drive further away because you drive faster. Sometimes if you're driving in the city, you probably will drive in less distance, right? So that means the speed the speed in any given time would be different. So how do you find the average speed from the 6 hours? Basically, they ask you that. So now let's take a look. Which one would be the output? So the output is the distance. The input is the time. So remember, the average rate of change is the change in output over the change, which is delta. The triangle means delta, means the change in output. So we want to find out the change from 0 to 6 hours. So the input from 0 to 6, so that means it's 6 minus 0. That's the change in input. What about the change in output? So on the 6th hour, your driving speed is what? Your driving distance is 219.2. So that means here's 219.2, and here in the first hour, the driving speed is 10 miles per hour probably. So that means minus 10. So here you will get 218.2 over 6, which is equal to 14.7 miles per hour. So that means on the first 6 hour, remember first 6 hour, because when it comes to 7 hour, it's different. We can check that later. When it comes to first 6 hour, your average rate of change is 70 miles per hour. So, does that make sense now? If no, we can give another example, such as what if I say, hey, find the average rate of change from the second to the fourth hour. Okay, I'm gonna use a green pens. So remember the average rate of change from the second to the fourth hour. I'm gonna use a green pen. So from the second hour, remember, is the change of output over the change of input. So we know the input is from the second hour to the fourth hour. So from the first example, we use 6 minus 10. In here, you can use 2 minus 4. That also works as long as the order of your numerator would be corresponding. That means I want these, the output of 2 hours, you're driving 90 miles. You drove 90 miles on the second hour, so that means you want to use 19, subtract 214. Which is negative 124 over negative 2. So the average rate of change in here is going to be positive 64 miles per hour. So look, you compare these two. The average rate of change is different. The first 6 hours is different than the middle 2 hours, right? Okay, so that's the average rate of change. But how do you compute the average rate of change of a given function? This is a table. So if I give you a function, given a function fx equals to x squared minus 1x on the interval, I should say calculate the rate of change on the interval from 2 to 4. How do you do that? So what's the definition of a rate of change? Average rate of change. Average rate of change is the change output over the change input, right? By notation, we have f of a minus f of b, and then a minus b. It just y1 minus y2 over x1 over minus x2. So what's fa? What's fb? What's a and b? Well, they're giving you the interval, right? From 2 to 4. That means our a is 2, our b is 4. Or you can do it the opposite way. Either way, it works. So if I can say this is our b, this is our a, also totally fine. So let's say 4 is equal to a. So I can write down 4 in here minus our b, which is 2. And then on the top should be what? F of 4 minus f of 2. That's it. That's how you find the average rate of change. Basically, it's the slope of these 2 points. Okay, so how do we find out f of 4? Well, f of 4 equals to what? You just substitute 4 into the function. So I have 4 squared minus 1 over 4, which is 16 minus 1/4. Equals to 16/3 over 4. And f of 2 equals to 2 squared minus 1/2, which is 4 minus 1/2, which is 7 over 2. Okay, and then we substitute these two into the function. F of 4 equals to 16/3 over 4, and f of 2 equals to 7/2. So now let me write these from the beginning. The average rate of change from the interval 4 to 2 is equals to f of 4 minus f of 2 over 4 minus 2. F of 4 is equal to 16/3 over 4 minus 7/2 over 4 minus 2. Okay, so this is fraction computation. You should have learned that through the prerequisite classes. So I'm not going to do that. So the answer would be 49/8. If you feel like you're not sure about that, try to compute it by yourself. If you have any question, let me know. Okay, so this is the average rate of change. Okay, so what if sometimes the average rate of change is on the interval that is not a number, it's a letter, such as I want you to find the average rate of change of the function f(x) equals to x cubed plus 2 on the interval a to b. How do you do that? So again, they should be the same. The average rate of change should be from fa minus fb over a minus b. A equals to what? Well, a equals to what? If f(x) equals to s cubed plus 2, let me use a denoted pen. So fa equals to, you substitute a equals to f cubed to the function, you have a to the cube plus 2, right? And then fb equals to I substitute x equals to b. So I replace all the x with b. So I have a b to the cube plus 2. So my function should be a to the cube plus 2 minus b to the cube plus 2 over a minus b. So is there anything that I should be aware of in here? Well, there's a big catches in here. It's very important. Is you subtract the whole function f of b, which is b cubed plus 2. So that means you need to put the parentheses. Why is that? Because you have a negative sign. If you forgot to put the parentheses, you'll forget to change the sign inside of the negative 2. So here should be a cubed plus 2 minus b cubed minus 2 over a minus b. So when we simplify, we have a cubed minus b cubed over a minus b. So by the difference of a qubit formula, these can be factored into a minus cube over a squared plus ab plus b squared over a minus q. So that means these two, they can cross cancel. When you simplify, you should get to the final answer, a squared plus ab plus b to the cube. So this is a little bit tricky. If you don't remember the difference of q, please to review it whenever that you can. Okay, so what will be the application of a business? Well, in business, average rate of change is related to the idea of margin cost and marginal revenue, marginal profit. So I'm not going to go in depth about it. I'm going to give you some idea. So marginal cost is typically defined as the change in the total cost if the quantity of the item produced increased by 1. Likewise, marginal revenue and marginal profit are the change in revenue and the profit if the quantity item increased by 1. Okay, I'm going to give you an example. Here is the example that I'm given. So a company has determined the total cost of the producing Q item is the function C of Q, 2000 plus 15 square root of Q. Okay, the function looks very hard, but don't be worried, it shouldn't be that hard. Find the marginal cost when the production is currently 5,000 item. So remember what is marginal cost by the definition. So by the definition, marginal cost is what? It's defined as the change in total cost if the quantity of the items produced increases by 1. So that's similar to revenue, marginal revenue. That means the revenue if the quantity of the item produced increased by 1. Remember, it's just increased by 1. So here, what's that mean? We want to find the increase in total cost when the increase in production from 5,000 items to what? Increase by 1. That means to 5,001. So basically, this is equivalent to finding the average rate of change from 5,000 to 5,001. Okay, so the first thing is what? We need to find out the cost. How much does it cost when you produce 5,000 items? So we substitute Q equals to 5,000 into the formula, which is 2,000 plus 50 square root of 5,000. This is equal to approximately is $5,535.53. And now we also need to find the cost when you're producing 501 products. One item. So this is equal to what? Use your calculator, you will find out that this is equal to 5,535.89 cents. Okay, so now we have everything that we need. So the margin of cost should be the average rate of change when the item increased by 1, when the production of the item, the quantity of the production increased by 1. So, 5,001 minus 5,000. Okay, so this is equal to what we calculated earlier, over 1. So this is equal to 36 cents. So the marginal cost would be 36 cents. So this is the marginal cost. So remember, basically you are finding the average rate of change on the interval from the current production to the current production plus 1, or increases by 1. So that's the application. So now I want to talk about the graphical behavior of a function. So when you see a function from the left to the right, if the function look like this one, like a W, maybe I should draw it nicer, like more like these. Okay. So in which part, when it comes to behavior of the function, we need to talk about increasing or decreasing, positive or negative, and then minimum and the maximum. Okay, so increasing, decreasing. So this is really straightforward. When is increasing? Well, when you look at it from the left to the right, the function, when you look at it from the left to the right, this part is increasing, right? And also this part is increasing. When they're going up, that's increasing. Agree? This is not hard. This is just how do you identify it. So what about decreasing? So decreasing, I'm going to use a blue pen. Maybe not blue. Let's use a yellow pen. Decreasing means the function from the left to the right is going down. So this part is decreasing. So what about positive and negative? So when it comes to positive and negative, I am going to draw another graph so it won't mess up. Let's use a black one. Let's use the same graph. Yeah, this is 2W. Okay. When it comes to positive and negative, let's say if it's a positive, that means they are above the x-axis. So that means when the value of fxy or the y is greater than 0. Where is greater than 0? Where is above x-axis? X-axis. This part, right? The highlighted blue part. That's when the function is positive. That means the value of fx greater than 0 or y value greater than 0. So when is negative? Well, negative is the opposite. Negative means they're below x-axis. Because when it's below x-axis, the graph is less than 0. The value of y is less than 0, right? So that means here is negative. Okay, maximum and the minimum. So let me use a purple one. Maximum. Let me use the graph on the top. Maximum, they're the same graph. Maximum is when the function from, where is it? When you look at the graph, you will say here, right? So what's special about here? The graph is from increasing become decreasing. Then we call it maximum. So do you say this point is maximum? Is this a maximum point on the left one? No, they aren't. Why is that? Because the graph didn't change the behavior from increasing to decreasing. You don't know what happened to here. This is blank. But from your prediction, what do you think will happen after that point? If you predict the function, it should keep continuing going up, right? If they didn't say anything, it should going up. So that means this is not a maximum point. Similarly to here, the left point in here, does the function from increasing become decreasing? We don't know because you don't know what happened in this part. In fact, it's more likely the function is continuing like this one, right? Keep going up. So that means this point is not maximum, even though the value of the y value is higher, but still doesn't mean a maximum. Remember, maximum means you have to changing the behavior from increasing to decreasing. So whereas I'm going to use a orange one, minimum means what? Well, it's the opposite. The function from decreasing become increasing, which is this point. This is a minimum point. Also, this one is a minimum point. Sometimes you will have a minimum bigger than a maximum. To be more accurate, we shouldn't call it maximum or minimum. They should call local minimum and local maximum. That will make more sense. So here is the graph. I can give you the example. In here, let me use the black one. Let me give another one. So which one is the minimum, which one is the maximum? Let's find the maximum in Wattpad. So this one is the maximum, right? Also, this is the maximum because the graph behavior changing from increasing and suddenly become decreasing. These are maximum. What about minimum? So minimum is the graph from decreasing become increasing, which is here is minimum, here is minimum, here also is a minimum. If you take a look, this minimum probably is higher than this maximum. So like I say, sometimes you will see a minimum has a bigger value than the maximum. Okay, so that's it for today. Let me know if you have other questions.